Seventh question. This statement is given regarding a right prism. A right prism with a uniform triangular cross section. So it should be a triangular prism. The cross section is a triangle. So that triangular cross section is uniform throughout the length of the solid object. That won't change. A right prism with a uniform triangular cross section has triangular faces. How many triangular faces are there? Here in this end, I have one. This end, I have the second one. So, two triangular faces and three rectangular faces. So, in this, when we take a front view, in this side we have one triangular face, one rectangular face, here another rectangular face, then the base. Altogether, three rectangular faces are there. Next question 8. ABCD is a parallelogram. DC has been produced to E such that AC is parallel to BE. This AC line segment is parallel to BE, so I can put an arrow. These two are parallel. If BE equals 6 centimeters, this is 6 cm, and DP 3. DP is the perpendicular drawn from point D to AC. So that perpendicular is 3 cm. Find the area of the trapezium ABED. Trapezium ABED. So entire trapezium, this one. So how to find area of a trapezium? First thing is that. What is the equation to equation of area of a trapezium? Area of a trapezium. There are two parallel lines for a trapezium. Only two parallel lines. So this is a trapezium. These two sides are parallel. Let me take these two as A. This is side A. This is side B. Then the perpendicular distance between the two parallel lines, we need that. I'll consider that as H. Perpendicular distance, perpendicular length between two parallel lines. We want that. Then area is half times sum of the two parallel lines A plus B into perpendicular height H. That is the equation of area of a trapezium. Then here, in this trapezium, the two parallel lines are DE and AB for the trapezium. Even though these two are also parallel, the two sides belong to the trapezium are these two, AB and DE. So how to find those magnitudes? If this is 6, if this side is 6, this is also 6. AC, that has to be 6 cm. ABCD. ABCD is a parallelogram. It was given. So here I can't find AB side and this DE side. So I can't use this equation. Here the problem is that I can't use this equation because these two AB and DE sides are not given. Then I have to use a different theory. This is the theory. These two lines are parallel. I can draw a parallelogram between these two parallel lines. Let me take that as ABEC. Then I can draw another parallelogram starting from the same base AB, that is ABCD. It is like this. So both parallelograms are between AB and CE parallel lines. Then the area of both parallelograms are equal. That is a rule. If we can construct two parallelograms with the same base, AB is the base, with the same base between two parallel lines, these two are parallel. This line segment here is parallel to this line segment. Then I have drawn two parallelograms, one in red color, A, B, E and C, the other one in black color. Areas of these two parallelograms are equal. That is a rule. The rule is area of two parallelograms drawn with same base and between two parallel lines are equal. So that is a geometrical theorem. Then we can find the area of, can we find area of a parallelogram? Any parallelogram here? Still no idea. But see here, this length is given as 6. I said this one before. AC is also 6. Then this perpendicular distance is given as 3. So first I can find the area of ADC triangle. Area of ADC triangle. That is half into base into height. Base is AC, which is 6 cm. Perpendicular height is the DP dotted line given 3. Then when we simplify, we get 9 square centimeters. Then another theorem is there. The other theorem is parallelogram can be divided into two equal parts by its diagonal. Diagonal bisect a parallelogram into two equal parts. Area of this part, this triangle is equal to the area of this part. So here in ABCD parallelogram, AC is a diagonal. So AC diagonal divides ABCD parallelogram into two halves. So I can take the area of ABCD parallelogram as 18, that is twice of 9. Area of ABCD parallelogram. ABCD parallelogram is 2 times 9, that is 2 times of ADC triangle, 18 square centimeters. Now that area is equivalent to this area, because earlier I said ABCD parallelogram is equal in area to ABCE parallelogram. Then this red color parallelogram which I am shading now, that is also 18 square centimeters. 18 square centimeters. This is half of that. Once again, this diagonal divides that parallelogram into two. BC diagonal. Then what can you say about this area? That is half of 18. Once again 9. Now I have all the parts. This blue color area is 18, area of the parallelogram 18, then this part is 9. So area of ABED trapezium, ABED trapezium is equivalent to 18 plus 9, 27, 27 square centimeters. Find the least common multiple. So first we have to write 4x square y in index notation. 4 can be written as 2 square into x square into y to the power 1. Then second one 6xy. 6 can be written as 2 into 3, that is 2 to the power 1, 3 to the power 1, into x to the power 1, y to the power 1. In order to find LCM, least common multiple, you have to separate each term into its index form. 3 is 3 to the power 1, y square. Now LCM is the product of highest indices. From 2, the highest index is 2 to the power 2, this term. Then from 3, 3 to the power 1. From x, we have index 2. So x squared is the highest index of highest term. Then from y, y square. Y square is the highest index term. Then take all those. 2 square into 3 to the power 1 into x square into y square. Now simplify. 2 square is 4, 3 to the power 1 is 3, 4 into 3 is 12. 12 x square, y square is the LCM. So arranging everything like this in index form and take only the terms with highest index and multiplying them will give you LCM. 10th question. A person who deposits 6,000 rupees in a bank for 2 years at an annual interest rate of 5%. Annual interest rate 5%. Compounded annually. So this is compound interest. Compounded annually receives 300 rupees as interest for first year. First year interest is 300. How much interest does he receive for the second year? So for the first year, interest is calculated in compound interest. It is like this. Interest is equivalent to the value. Deposit here is 6,000 into number of years is 1 because this interest is for the first year. Time period is 1. Interest rate is 5%. 5 over 100. Cancel 2 zeros. Then we have 5 into 60, 300. So it is given, so no need to calculate that. 60 into 5, 300 is given. It is already given, so no need to calculate. Then they are asking what should be the interest for the second year. Now, when taking interest for the second year in compound interest calculation, we have to add our interest in first year to this deposit. That is the special thing. Principal means the deposit in this case is 6,000. Add the first year interest to that. That will be the principal for the second year. That will be the deposit for the second year. That is the only difference. So not 6,000, this becomes 6,300 into first year. Again, the second year means the time duration is 1 year. From first year to second year, no, time duration is 1. Percentage won't change, it is 5%. 2 zeros get cancelled. Multiply 63 by 5. 5 times 3 is 15. 1 remaining. 5 times 6 is 30 plus remaining 1, 31. So this is the answer. 315 is the interest for the second year. The most important thing is you have to add the interest of first year plus deposit when you consider that for the second year. That is the most important thing. Then if in the question they have asked for the third year, then you have to add the deposit plus interest of first year, interest of second year when you go for the third year. That is the pattern in compound interest. Question number 11. The first quartile of a collection of data arranged in ascending order is in the fourth position. In which position is the median of this collection of data? So, data. So, for an example, let's take we have this set of data. So, I have considered 1, 2, 4, 5, 5, 6, 9, 7 data. Here we have 7 data. N is 7. Q1, that is first quartile, that is calculated by this equation n plus 1. N is number of data divided by 4. N is 7, so it is 7 plus 1 over 2. 7 plus 1 is 8, sorry, not 2, 4. 7 plus 1 is 8, 8 over 4 is 2. This is not our Q1 answer, this is the position of Q1. Second data, so second data is Q1. So second data given here is 2. So first quartile is 2 in my data set. Then I am going to calculate Q2. Q2 is also known as median. Q2 is also known as median. Half. So Q2 is n plus 1 divided by 2. N plus 1 divided by 2. So what is n? 7. 7 plus 1 divided by 2. 8 over 2e is 4. So fourth data. So fourth data in my data set is this 5. So second quartile is 5. Then third quartile. Third quartile is 3/4. 3/4 of n plus 1. Once again, what is n? N is 7. 7 plus 1 is 8. That means 6 data. I have to take the 6 data. Count 1, 2, 3, 4, 5, 6. 6 data is 6. So this is the way of calculating Q1, Q2, Q3. So Q1 is 1/4 of n plus 1. Q2 is 2/4. 2/4 can be written as half. Half of n plus 1. Q3 is 3/4. So it is clear. Q1 is quarter. Q3 is 3/4. Then Q2 is half. So half of a data set, quarter of a data set, 3/4 of a data set. That is calculated in Q1, Q2, Q3. So in this question, in our problem, the first quartile of a collection of data is at fourth location. So that is there in fourth position. So we have to find the position of the median. Median means Q2. So fourth position, that means Q1 is in fourth position. So what can you say about Q2? Quarter of a data set is 4. Half of that should be twice of 4. That is 8th position. Because Q1 represent quarter, Q2 or median represent half. So I can take Q2 by doubling the position of Q1. Position of Q1. So in which position the median of this data collection of data? Answer is 8th position.